Well, I'd like to welcome all you to our presentation tonight. I'm assuming you came here for two reasons. One, because the subject of Daniel Dennett and Darwin's dangerous idea sounds like a delightful subject. And the second reason you're here is because you know Gordon Orians knows everything there is to know about everything there is to know about. So I don't have to give any introduction to him. I just do an Ed McMahon thing and say, "Here's Gordon."
Thank you, Bill. I do have to acknowledge, though, that my ignorance is vast. And I have special knowledge about a lot of things, and there's a lot of things I don't know anything about. So anyway, you may be intrigued by the title. I assume that most of you have heard about and know something about Charles Darwin. I will probably convince you in the course of this talk that most of what you think you know isn't true, because the reporting on this and the way it's in the media get things all distorted. But I'm quite sure you probably don't know and not heard of Daniel Dennett. So before we go on any further, let's talk about Daniel Dennett. Daniel Dennett is a philosopher. Born in the United States, spent most of his career in the philosophy department at Tufts University in Boston, and the same university where my son has a professorship, and his office is just down the hill from my son's, and that's where I have met with him. Daniel Dennett is one of these philosophers that realized if we're going to really talk about evolution and what's going on in the world, you really have to understand the science. So he invested very heavily in learning about biological science, genetics, natural selection, everything. And here's the book, Darwin's Dangerous Idea. And this is written by somebody who knows more about evolution and natural selection than 90% of biologists. Okay? That may be damnation by faint praise, I'm not sure. But also, Dan Dennett, as a philosopher, is interested in a lot of things. He's a part of the group that formed the Freedom from Religion. He's been very much interested in the secular society and developing, working with pastors who no longer believe what they're teaching and trying to help them transition. He's also very much interested in a materialistic world. How can ethics and freedom evolve? And he's got a little book there on the far end I brought is because freedom evolves. And he said in a deterministic world, how you can get enough of what we will call freedom worth having. He's also very much interested in and critical of the fact that often religious people and their ideas hide behind a veil of ignorance. And they say, this can't be investigated because it's my religion. And Dan Dennett is a great fan of getting rid of that. And he's got this book here I brought is called Breaking the Spell. And that is how can we, when the religion is actually making claims about how the world works, these are claims that are amenable to scientific investigation and should be handled that way, but they won't do it. And he's been very active in trying to get the spell broken, how to open it up. And he's not done very well. One last thing here. If you don't want to invest much time in that, this is a little book by someone else. It's called Daniel Dennett, and it's just part of a series of contemporary American thinkers. And this is a view of Daniel Dennett as seen by somebody else. And that's always dangerous because, as we know, throughout human history, leaders have tended to have more trouble with their followers than with their enemies. So, but this is pretty good, okay? So, that's Daniel Dennett, and he is very worth knowing. He's really a profound thinker, and this book, Darwin's Dangerous Idea, is things. One of the things he talks about, he compares cranes versus skyhooks. And the crane is the way we build this up, knowing the stuff the way he thinks we ought to do. But when people have trouble, one of the first things they want to do is bring in a sky hook to help them up. And that's one of the first, and that indicates how well he can express things. And one of the things, scientists are often critical of philosophers because they don't discover anything. Well, that's true, but that's not their job. Their job is to raise questions, analyze, and help you think. And then it realizes this. Darwin's danger. He isn't explaining evolution. He's showing these are the things that scientists need to do to provide answers to these things. So that's Daniel Dennett, and the bottom line is, I think he's really worth knowing. I think he's one of the intellectual giants in this country in the last century, and he just died a couple of weeks ago. And he was the last of one of the four horsemen of the apocalypse, Richard Dawkins and he and Sam Harris and Christopher Hitchens. And now with Dennett gone, Richard Dawkins is the only one that's left of those four. Anyway, so now, since Daniel Dennett isn't here and can't speak, what you're going to get is why Gordon Orians thinks Darwin's idea was dangerous. Okay, and I think this is a lot like what Daniel Dennett would tell you, but he's not here to defend himself. So right now I happen to agree with him that Darwin's idea is dangerous, and you'll have to take it from me now. And to give you the punchline first and then work back, it's Darwin's idea was really dangerous. Oh, this is The Origin of Species, by the way, the book, and I will quote from it later. But Darwin's idea is really dangerous for two reasons. First is it says there's creativity and all sorts of design, and there's no designer. We can get, and he's saying, I'm going to give you all this beautiful variety of biological world, and it doesn't need a designer. And everybody thought there had to be a designer where you design, and I've got a mechanism, and I'm going to explain how we can get design without a designer. And that's a real flip of causal thinking in Western society. If there's design out there, wings are for flying, well, somebody had to design it. And Darwin, for the first time in the history of Western thinking, says, no, I got a mechanism. It will give you design without a designer. And we'll describe what that mechanism is in a few minutes. The other reason it's so dangerous, it says, look, you brainy ape, you're just one little twig on this marvelous tree of life. The world wasn't made for you. You're just a part of this process, and get used to it like all the rest of us. And that idea, what is happening is it's knocking us off a throne, but elevating the rest of life. And that's pretty dangerous. And whereas I think the first of the two reasons is far more important, guess which one has attracted the most attention? The other one, okay? And we'll see how and that's still being played out today. So that's the introduction. So let's go on to what did Darwin really do, and what was the state of the world when he did it? Well, by the time, and Darwin was 150 years ago when he was doing all this, and it was pretty well accepted that there was biological evolution. All the real thinkers thought the problem was how did it happen? And nobody had a clue how it happened. And the geologists began to realize that the Earth was pretty old, that the idea of really only 4,000 years or so from Genesis was wrong. But looking at the Grand Canyon Wall, you could see there was a lot of time there, but they had no idea how much time. And all they could tell the changes, what was happening, was the animal fossils in the rocks. So all the names are Proterozoic, Cenozoic, Zoic, named after the animal fossils in the rock. And it wasn't until 1900 that we learned how to tell how old things were. And that was a contribution made by a French woman Marie Curie, and she discovered radioactivity. And radioactivity is giving us the means for aging things. And everything is aged now by using different radioactive decay of different elements. And I won't go into it, but the point is, it was 1900 when we learned how to tell how old things. So Darwin didn't know how old things were. Nobody did. The geologist sort of said, and the only book he carried with him was Charles Lyell's Principles of Geology. And Darwin was really quite a geologist, and if you read The Voyage of the Beagle, which is a wonderful read, you can see how his ideas were developing. He talks a lot about geology, making geological observations. And in fact, he developed a theory for how coral reefs formed, and that's still regarded as correct. So Darwin talks a lot about geology. He was a part of this effort. We think biological evolution has occurred, but how did it happen? And actually, there were other thinkers that have thought about the famous French anatomist Buffon had developed a theory. This is how it happened, and it's often pictured as the giraffe straining its neck to reach up to the leaves of an acacia tree, and the giraffe that is able to stretch and get its neck up there and feet up a little higher had a benefit of a better condition, and it was better at reproducing. Interesting idea. The trouble is it's all wrong, because that doesn't change the genes, and what the giraffe is going to pass on to its offspring has nothing to do with how much dad or mom stretch their necks. It's a great idea, but it's wrong. But in all credit, he was trying. He was working on it, and everybody was having trouble figuring this out. And Darwin. And everybody thinks, he went to the Galapagos Islands and saw the finches and thought of evolution. No, he got it all screwed up. He messed his finches up. John Gould and the ornithologist at the British Museum had to straighten him out. Darwin was influenced by what he saw there in the relationships, but he didn't get it right then, and he struggled a long, long time. But finally, this is what the idea he came up with. We knew something that there were genes. We didn't know what they were, how they worked, but we knew there were chromosomes, and we knew that they were dividing, and you had to do duplication and stuff for every reproduction. So Darwin realized that there has to be duplication of the genetic material a couple times during every life cycle. And these are not likely to be perfect. They're not likely to be error-free. And most of them that are wrong, or they're errors, are going to be disadvantageous. And he said they're going to die out quickly because the individuals that pick those up are not going to be healthy. But a few of them might actually improve things. And that those then, the individuals that inherited those variations might survive better, have more kids, and if that continued for a while, you'd get evolutionary change. And so it's the fundamental idea is it's simple and depressing in a way. It's DNA. We say DNA copying errors. Now he didn't know DNA, but it is a theory of copying errors, that most of which are not helpful, but a few of which are. And Thomas Henry Huxley, who was Darwin's bulldog, read it and said, "How stupid of me not to have thought of that." But he was wrong. It was really hard to think of, and Darwin struggled, and nobody had thought. It's one of these things after he told the answer. Well, why didn't I think of it? Well, it's one of those things that's maybe somewhat obvious after the fact, but it sure as hell wasn't before. So this is the kind of thing that Darwin mentioned. Now, and so he had all of this book says The Origin of Species by Natural Selection is really one of the worst titled book in history. It has nothing to do with the origin of species. all it does is say that species can change, and it has no example of natural selection, because there weren't any yet. Okay? That's not Darwin's fault. There weren't any, because nobody had thought of it yet. But Darwin says this is a testable idea, and we spent a lot of time in the 150 years testing it. So that's what Darwin proposed. And Darwin was a fiddler, and he monkeyed around with it, and he had been working on this for a long time after he got back from the Beagle. But he was very cautious. He was a cautious man, but he was married. He was very concerned about his wife. He was married to Emma Wedgwood. Yes, that Wedgwood. And they were very much in love, had kids. And she was his first cousin. And we all know now if you have an outbred population that start inbreeding, this is trouble. Sort of recessive things are likely to come up, and they actually had a little bit of problem with their kids, actually. But he was really worried. He loved his wife, and she was very devout, and he was afraid. And I think we don't know how long Darwin would have fiddled around with this until a very shocking event occurred. And this is now known in history as the letter from Ternate. And that's the island. It's from the island of we now know as Sulawesi in the East Indies. And there was another biologist out there by the name of Alfred Russel Wallace that was out there, and he was very poor, and he was making a living by collecting plants and animals and shipping back and selling them to people in England. So he was a very astute observer of the stuff going on. What was this? And one period he was recovered, laid out with malaria back, and he wrote this letters he sent to Charles Darwin, which we now know the letter from Ternate, in which he made a perfect statement of the theory of natural selection. And Darwin was just petrified. He had been working, he said, I've been scooped. This guy's got it. And it's a perfect statement. If you read it, it's really good. But Darwin's friends knew he was working on it. And so they arranged for a meeting of the Royal Society. Darwin quickly made a presentation, and Wallace's paper was read, and both men were given credit for the theory of natural selection. And then Darwin worked like hell to produce this right away afterward. And this was intended to be the shorter version for something longer. Fortunately, we're spared to the longer one. This is all we need. So Alfred Russel Wallace forced the issue. And if it hadn't, we don't know how long. It could have gone on for a long time because Darwin was really fiddling around with it. And Darwin gets all the credit, but don't feel too sorry for Alfred Russel Wallace, because he was the founder of another discipline, biogeography. And he was out there in the Indies, and he noted that he could sit on the island of Lombok and look over to Java, and there were elephants and bears and monkeys. And look the other way, in the other direction, he could see it. There were cockatoos and marsupials. And he recognized this is an incredible thing, and he figured out what it was. That looking to the west, the Sunda Shelf, where Borneo, Sumatra, and all these islands are, very shallow water, and during the peak of the glaciation, when sea levels dropped, you could walk all over those. So they're populated with big mammals from all over the thing, and sea level went up, and now it's isolated. But deep water going the other direction, and Wallace figured out that mammals could get there, and mammals are rather poor crossing salt water, and other than bats can fly, and bats got through. But he correctly figured this out, and he's the father of biogeography. And if you take it, that we still in the literature, so there's Wallace's line between these two. And so Wallace was a great genius. Darwin gets all the credit, which is okay, but Wallace got his, and he's the father of biogeography, and it's a wonderful discipline. I had the pleasure of teaching it for about 10 years at the university. It's wonderful to study why plants and animals are found where they are and not where else, and how these distribution patterns have come about. And just one little aside here. I'm tempted to asides because the asides are so absolutely fascinating, and you'll bear with me, that biogeography, all the early stuff was before plate tectonics. The continents were all assumed to be where they are. And so you should see what the biogeographers went through to try to explain everything without any movement of continents. Special bridges. It was amazing. And if you read the biogeography literature before plate tectonics, which is a lot of it, because remember, acceptance of plate tectonics, that's in my adult lifetime too. This is all recent. The discovery of plate tectonics made all of previous biodiversity by theorizing irrelevant, and the discipline had to redo itself. And the last group of scientists that refused to believe in plate tectonics were biogeographers. Surprise, huh? Okay, so, science is a form of human behavior, okay? And it's got all the warts. It's wonderful. It's exciting, but there it is. It's got all the warts and things. So anyway, but in general, then there was this big dispute, and all the dispute was about really, so am I a monkey, kind of thing, that are we dethroned, and not about the real important thing of design without a designer, which is what it ought to have been about. That's not what concerned this Homo sapiens. And there were big debates, and there were, Huxley who was Darwin's bulldog. Darwin was a very quiet man. He was sick a lot. He may have gotten Chagas disease while in Brazil, but he was pretty sick and didn't do much. But Huxley was his bulldog, and they had a debate with Bishop Wilberforce, who once said, "On which side from the monkey are you descended? Your father's side or your mother's side?" And all of this wonderful. But the point is that what attracted most of the attention was not what I think was the most important thing, was this thing. And it still goes on, as we will see. We're still playing that game. So anyway, that said, then biologists went to work in discovering and testing Darwin's ideas and finding all sorts of new examples of natural selection. We start building up a literature. But Darwin didn't stop there. He wrote a number of other books, and one of the books was on how earthworms change the nature of the soil. And he performed experiments, putting little discs out in his garden and watching how fast earthworms buried them. Darwin was the first experimental ecologist. He didn't know he was. The field hadn't been invented. But Darwin founded the science of ecology, although he didn't know it, and the first books in ecology came out about 40 years later. So he also thought more about natural selection and wrote a book, The Expression of the Emotions in Animals and Man. And this is a foundation book for comparative and evolutionary psychology. It's an amazing book. To read this, he sent letters out to all over the world, how people expressed and everything. But he developed a theory of sexual selection, that a lot of traits were selected or favored because they helped you in gaining access to a mate. And this now it's all accepted. Of course there's sexual selection, big deal, right? It was really, really, really problematic because guess what? Who was making the discriminations and driving it? Females. think of Victorian men. Women are driving this, and they're not good enough to vote now, and they're running evolution. No way. And so the sexual selection really hit rough ground, and it was a long time before it got accepted. And I've given you my interpretation of what it is, but I think that's what it is. Again, that females are doing this? No. The females aren't going to be that smart, Okay. But we now know that the way sexual selection works in most of these, it is primarily female-driven. Okay. So Darwin is continuing and doing interesting stuff. A lot of people are developing new ideas and following this out. But there's one big gorilla in the room. That's genetics. Because Darwin believed, unlike everybody did, in blending inheritance. And the offspring will be intermediate between the parents. And this is what you see, since most traits that you wanted to look at are determined by many, many different genes, that's what it kind of looks like. But the problem with blending inheritance is that every generation you lose half of your variability. So variability disappears really fast. And Darwin knew that all of his ideas depended on variability. And he was looking, you could see all this variability out there. What preserved this variability? And Darwin knew that something was wrong with genetics. He spent a lot of time trying to develop a theory of genetics. It's called pangenetics. And it was a colossal failure. And we now look at it just like historical, and say, okay, he recognized the problem. Sorry, he couldn't figure out the answer. But the interesting thing was the answer was available. At the time, the answer was available. At the same time that this was going on, there was a little monk in a monastery in the city of Brunn in Austria, who got interested in genetics and was testing genetic ideas with pea plants in his garden. And so this is Gregor Mendel, the man with brilliant genius, and he founded the science of, the modern science of genetics begins with the publication of Mendel's paper. And so so you get white peas and red peas. He doesn't get pink peas. He gets white and pink. The variability is preserved. And so what Mendel shows, and the experiments show, that no, the genes don't blend. It's particular. The variability is maintained. And what Mendel's experiments show that variability doesn't decay. It's maintained unless something acts to decrease it. So there's no problem in variability being preserved. Now, and the big question is, did Darwin read? He could have read. It was not. But whether or not Darwin, and the point is that nobody who read Mendel's paper figured out how important it was. And Mendel must have been very disappointed because nobody paid any attention. And apparently he went on into monastery administration and probably was kind of sad. And it wasn't until after he died. And when that happened, that was 1900. And a Dutch geneticist, Hugo de Vries, read the original paper and said, wow, there it is. There's the variability. That's the one. But then what happened? Then it was all genetics. We don't need Darwin. It's all genetics. And Darwin went into a decline. Nobody paid any attention to Darwin then until around 1930, when three brilliant biologists figured out that Mendel and his experiments provided the problem that solved Darwin's problem, and bringing the two of them together made us the modern synthesis. And this is about 1930, 32. Three people, one of them, two in Britain and one in the United States. And one of them was R.A. Fisher, who published an amazing book, The Genetical Theory of Natural Selection, which is one of the great books in evolutionary biology. And he's also the inventor of modern statistics, brilliant man. The other was J.B.S. Haldane, who was quite a flamboyant character. And one story is he was supposedly at a dinner party and sitting next to a clergyman from the Church of England, who asked him, "What have you learned from the study of creation? What does it tell you about the Creator?" And Haldane is supposed to have quipped, he was inordinately fond of beetles. In fact, there are more species of beetles than any other kinds of insects. So, and the third was Sewall Wright in the United States, and he worked on the inheritance of coat color in guinea pigs. He lived a long time. I actually met him. He was about 95, and was just publishing his last paper, and still smart. And he had some sort of a genetic problem, and so they refused to give him life insurance. Boy, did they miss out on that one. So anyway, these three. So what happened? These three people conceived of the modern synthesis, what brought together Mendel and Darwin. And see, that span, that happened the same time I was born. So all of this has happened within my lifespan. So much of what happened and what is the burst of stuff that has made evolutionary biology so incredible, that's since 1930. It's not 1850. And so the history of this is much more complicated, and it's far more interesting and fascinating. So that went on, and so that this has created the modern synthesis. But so this and that has taken the sort of attention away from the just are you a monkey or not? People got less interested in that. But this has continued, and it's still a major thing. And I think it was 1975, Ed Wilson wrote this wonderful big fat book called Sociobiology. And it was looking at what we understood about the evolution of social systems and living organisms, going everything from bacteria on up. And a wonderful book. And nobody had any trouble with octopi and rhinoceri. But the last chapter is human evolution. And that's when the fecal material hit the ventilating apparatus. All hell broke loose then. And because the idea that human genetics could be interesting, human genetics, how we were behaving and what we were doing. And interestingly, where the attack came was not, well, there was some from religion, but it was the far left, the leftists, the communist leftists, and this was led by two very prominent biologists at Harvard, Richard Lewontin and Stephen Jay Gould. And you may know both, and they formed the Science for the People. They were the ones that caused their followers to go up and throw water and tomato juice in Ed Wilson's face and everything. There was this whole thing that attack on sociobiology and evolutionary biology from the communist left. Now, why was there such a big for the communist left? It was because the vision they had about the new society is that you could make the human participant anything you wanted. The new man or the woman, the person, there were no constraints on this. And what Ed Wilson and sociobiology and Darwin are saying, no, we are an involved organism. We got genetics. It's affecting what we do. And there are constraints on this, and we need to know about human genetics and human behavior and how that works. So this was really an unbelievable attack that came, and attacking all sorts of things, optimality modeling. I know both of these guys. I actually got caught up in a debate with Lewontin, something I was doing on optimality foraging, and he couldn't. That was something that was not permissible. That you optimality for the whole business of this. It really got ugly, and we're still coming out from that, where. This is a politicization of science coming from the scientists. And this is awful, really, really bad. And we're still coming out of this, but mostly we've recovered. And Ed Wilson won, so to speak, this particular debate. But and this happens to be an area that I've spent a lot of time doing research on. My book on human evolution, and which is in the library. I was involved in participating in this. So anyway, this we did have an awful phase of anti-Darwinism coming from the political left and led by scientists, which is really sad, really, really sad. So that's still where we're having troubles with. Am I a monkey? kind of thing, and so that's still we're still having trouble with both of these things of this dangerous idea. One is that what's the meaning? Where's the meaning out there? And it basically says we want there to be meaning. We want the meaning in evolution. We want natural selection be for the survival of species. A lot of people want to think that. Well, it isn't. It says nothing about the survival of species. And besides, if that's what it's about, it's been a colossal failure. Well, over 90% of species that have ever lived have gone extinct. That's a pretty bad track record. Well, but that's not what it's about. It has nothing to do. But we want meaning like that. We want a moral arc in the universe that's somehow bending towards something. And the really dangerous thing about this, it says that ain't there. There is morality in the universe, but it's created by the evolution of complex societies of animals that develop ethical things, which is impossible to function in a society without them. But morality has evolved, but it's biological processes and complex societies, particularly primates. And we're, of course, the most astounding example of that. And the other, we're still having trouble with, are we really only just a twig out there? Okay, we got big brains, but we're dependent utterly on plants, and plants tell us that you can have tremendous success with no brains at all. I find that kind of depressing, because I tend to, but we tend to, and I like my brain, but this whole thing says, look, there's another twig out there. This world isn't for you. And coming to grips with that still is hard. So the true problems, the major things that are dangerous about Darwin's idea, we're still grappling with. And it can sound pretty bad, but I've got hope. And Darwin was not a wonderful writer. You read, don't pick this up for easy reading, okay? But the last paragraph of the book, Darwin waxes a little bit eloquent. And I'd like to read to you the last paragraph from The Origin of Species. It is interesting to contemplate a tangled bank closed with many plants of many kinds, with birds singing in the bushes, with various insects flitting about, and with worms crawling through the damp earth, and to reflect that these elaborately constructed forms, so different from each other and dependent upon each other in so complex a manner, have all been produced by laws acting around us. These laws, taken in the largest sense, being growth and reproduction, inheritance, which is almost implied by reproduction, variability from the indirect and direct actions of the conditions of life, and from the use and disuse, a ratio of increase so high and so lead to the struggle for life, and as a consequence to natural selection, entailing divergence of character and extinction of less improved forms. Thus, in the war of nature, from famine and death, the most exalted objects of which we are capable of conceiving, namely the productions of higher animals, directly follows. There's grandeur in this view of life, with its several powers, having been originally breathed by the Creator into a few forms into one, and in that whilst this planet has gone on cycling according to the fixed law of gravity from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved. Endless forms, most beautiful. Isn't that wonderful? And what's wonderful, not only we can now understand how this endless forms are being created. Each year we know more about this, and we know about human evolution, and we know where we came from and why we're here. We're getting answers to these great big questions, and it's marvelous to understand that we can comprehend. Our brains are such that not only we're making incredible progress in understanding this, and each year we know more. And to me, that's just an exciting, wonderful view of nature. It's that we can participate in this, we can understand this unfolding of things most diverse and beautiful. So, who could ask for anything more? Who could ask for anything more?
Questions?
Flattened with wisdom.
So somebody can ask for something more, surely.
Yep, I will. I've always said the bugs are going to inherit the earth. And you indicated that, there's something about bugs. Somebody said that God was so interested in bugs more than humans. Well, what about that? There are a number of species that can disappear, and we're the ones that, if we disappear, life will go on in this world. But a lot of other things, if they disappear, then a lot of life would die. So are we really that insignificant?
Well, we are insignificant in the sense that we're one little twig on the thing. We're very significant that how we've happened to evolve and what we're to do with the place. We've been a major cause of extinction. We've caused more species to go extinct than any other, when we're still in the great big extinction. We're changing the physiology and the climate of the earth. So in that sense, we really are significant. And it's because of this brain we got that has enabled us to do all this stuff, and we're rather good at eliminating stuff. But so we really are, in that sense, unbelievably significant, and we got to act as though we are. But in terms of evolution and how just one little twig out there, one little twig, and it's important to remember that. Because otherwise we can get over-impressed with our importance. But we are unbelievably important, and it's terrible what we're doing, okay. But, so, in the one sense, it's trivial, but I think you get the difference. You know.
Gordon,
Yes.
this is Peter. You are so brilliant. I'm counting on you.
Uh-oh.
I'm counting on you to be able to figure out the theory of political evolution. How do we take these brains we have and create such a mess? Or maybe something beautiful.
Oh my God. Can I take the fifth? No. I mean, this is until fairly recently. Again, remember I gave a talk not too long ago on the evolution of deceit, and it wasn't too long ago that you could tell who the deceiver was, and you developed good crap detectors, and it worked out. Now we've developed this complex thing. And the world is full of misinformation, and we can't tell where it comes from and where it's going. And we've created an environment which I'm not sure our brains are capable of handling. I'm pretty scared, as a matter of fact, of what we've created and our ability to handle it. But this is the byproduct of this marvelous brain of ours, which enables us to ask questions like, where have we come from, where are we going? But it also enables us to do these unbelievable things, this changing the climate of the earth. And we've exterminated more species than anybody else. You know, we're the big exterminator. I don't have anything, I don't think, terribly useful to say, but I'm scared, really scared.
Gordon, could I ask, and this little twig invents something called artificial intelligence. Is that real, or is that going to change the shape of things that we know, or is it just another device that changes things a little bit? Is it going to be a major change?
Well, again, I'm starting to get asked questions that are really not in my area of expertise, that I know anything more about than you do, and so I have to disappoint you in a sense. But what is quite clear is that one of the things that has always been a part of science is imagining things that aren't. And a lot of sciences, for example. One of the things that's obvious that nobody asks any sex. Why are there just two sexes? Why aren't there three or four? So people started making models of 3 sexes and 4 sexes, and they all collapse onto 2. So the reason there are only 2 is that the others are unstable. But so we do a lot of thinking, imagining things that aren't, and artificial. This intelligence is incredible. It creates an enormous amount of stuff and enables us to imagine stuff that isn't. And that's always been an amazing and essential part of science, much more than people realize. And you say, oh, follow the facts. Huh? You know, that's what it really is. And the description of the scientific method we get, here's, given a hypothesis, you do that. Whoa, wait a minute. The creative act you just bypassed, given a hypothesis, where the hell did the hypothesis come from? So a whole description of the scientific method leaves all the exciting part unstated. So we are very good at counterfactuals and bringing this up. And what we learned with artificial intelligence, if you feed the machine with an incredible amount of information, stuff it up, it can cough it back. And I don't know where that's going, but the process, as I see it, is pretty much continuation of what we've done all along. And I worry that it's like all these other, it's getting out of hand. But you're really asking me, unfortunately, things that I'm no more competent to answer than you are.
Gordon, I'm interested in this wrinkle you talked about with Lowenstein and company of ruling out biological determinism of any kind in the interest of, complete malleability of human nature, which, I mean, partly that was a reaction against the racists who wanted to establish a racial basis for intelligence and so on, as I remember. I wonder if you could talk a little about how all that settled out and where we are today on biological determinism.
Well, all of this stuff was terrible, of course, because people, the white northern Europeans, and particularly the Brits, figured that everybody else was inferior. And you tried to measure black brains and do all this crazy stuff that was going on that was all trying to demonstrate that we are superior to they. There was no scientific basis for any of that, but that was, if you're trying to subjugate somebody, the best way to do that psychologically is consider them not human. And if you've been for boot training in the Army, the biggest thing, we've spent about 5 minutes learning how to shoot a gun, and about hours figuring out how to buddy and think bad things about the other people. And so we've always wanted to, different groups of people thinks that we're better than somebody else, and none of there's far more genetic variability among human beings in blacks than anybody else, because we're all descended from a little bit of population that got out of Africa with very little genetic variation, and the vast amount of genetic variation is found in African populations. We're impoverished, so it's what we want to believe and what is actually true are just so different. But there's the in-group, out-group, and we want us as members of the in-group to be better than the out-group. And if you're going to fight or do anything nasty to somebody, it's always a lot easier to do that when they're not really human. Pardon?
The other side of the coin is that biology doesn't determine behavior. That's
It's hard to hear you. Let's get the mic back.
I was interested in the connection with the controversy you talked about, which is that genetics doesn't count for anything important in human behavior, according to Lowentin and company. Isn't that correct?
Yeah, that was what the left-wing attack was. That the model was that we can create this new society, and we can the human being that we need to fit into that is easy because there's no constraint on what it is, and what Ed Wilson and what Darwin is saying, that we are an evolved animal like everybody else. And I've worked on this in my book, Snake, Sunrise, and Shakespeare. Evolution Shapes Our Loves and Fears is my effort to see how the way we look at an environment and the way we evaluate things and why we find some trees prettier than all of that is part of our evolved nature. And that gets important in how we're going to design parks and other sorts of stuff to be pretty. So that's just my little involvement in that. But already we know from our work on the complex politics of baboon societies and ape societies that they develop all of these complicated things. And compared to insect societies, there's only one discrimination, in-group or out-group. If you got the right smell, you come in. If you got the wrong smell, you're killed. And there's only one discrimination that complex society makes. There's only one. But ours are, the primate societies get very, very complicated, and the way we work out all these things. But evolution, what I think we're discovering, we've got better and better literature on this, that our evolutionary self does make a difference. And the societies the people that want to create societies that we can put whatever kind of human being we want in there, they found this not good. They don't like it. And it's amazing what they did to try to prevent it, but it was a pretty sad stage in biology to be attacked by fellow biologists because you believed in evolution. It was really.
One more.
Irwin.
Factors that influence the pace of evolution. The reason I ask is I've been doing some reading about human life 5,000-6,000 years ago, and I find myself tremendously impressed with how much change has taken place. Is that an evolutionary kind of thing? And what are the factors that influence evolution across species?
Okay, this is a major question. What is the speed of evolution? How fast do things happen? And the answer is it's extraordinarily variable. One of the problems we're facing today, a big problem, how fast viruses evolve, right? And how fast bacteria evolve, how much we have to try to keep ahead of them as they're evolving. So some things like that go really fast, and particularly when we are fighting against an enemy like bacteria, where the life cycle is 20 minutes. Okay, and as a matter of fact, the main reason half of us in this room are here, that there's sex and there are males, is that's part of the way we fight against bacteria. And so things are highly variable. Speciation in plants are very, very different than animals, can go really fast. The formation of species, which is a part of evolutionary biology, and speciation theory is a big part. That can go really, plants can speciate in one generation, because you get increase in the number of doublings of chromosomes. You can increase in the number of chromosomes has been very important in plant evolution. Our bread wheat has got 6 copies of chromosomes. It's hexaploid. Most of us are diploid, got 1 copy each from mom and dad. So it's highly varied. So evolution can be very, very fast. It can be very, very slow. A lot of what we've seen in the changes in human societies are probably not genetic. They're cultural, and that we got ideas, and this is something that Richard Dawkins promoted, the idea of memes, where ideas can spread, and ideas can spread really fast, and they don't depend on genetics, and because genetic evolution for the stuff we want is usually too slow. And this is critical for the problems we're facing, how we're going to deal with the problems we create. Genetics isn't going to help us out, folks. It's going to be too slow. We got to figure it out non-genetically. So, but the study of how speciation occurs, and all speciation theory and how it happens, because it appears we're from one common ancestor, and we've got millions of species, so there have got to be millions and millions of speciation events. And how they happen, what drives it, this is one of the exciting areas of biology, and it turns out to be one answer doesn't fit all.
Once again, Gordon has shared his vast experience, and we thank you, Gordon, and I hope you'll stay for any further questions.
I'm not going anywhere. Thank you.